Have you ever stopped to think about the invisible components really powering our modern world? Those things humming away behind the scenes in factories, robotics, even in the device you might be listening on right now. Today, we're doing a deep dive into something specific but really important: Optoelectronics IGBT and MOSFET gate driver photocouplers. Bit of a mouthful, I know. Our mission here is simple: give you a shortcut to understanding this, well, crucial piece of power, electronics in computing. It's often overlooked. Think of it like getting a look under the hood at what makes so much tech work safely and efficiently.
Exactly. And what's fascinating really is just how fundamental these things are. An optoelectronics gate driver photocoupler, it basically acts like this invisible bridge.
Mhm.
It uses light, actual light to send control signals safely. It goes between the, let's say, the delicate low voltage brain of a system, like a little microcontroller, and the really powerful high voltage muscles, things like IGBT or MOSFET transistors.
Right, so it keeps the sensitive parts safe from the high-power stuff.
Precisely. That separation, that isolation is absolutely critical. Think about electric vehicle chargers, big solar inverters, industrial motors. In all those cases, safety and precision are paramount. Yeah, you absolutely cannot have high voltage frying the sensitive control circuits.
Okay, that makes sense. And looking at the market impact, I mean, that really underlines how essential they are.
Yeah.
This isn't some tiny niche, is it?
Not at all. It's a rapidly growing segment.
Yeah, the numbers are pretty striking. Total global sales revenue back in 2021, it was already $193.05 million.
Mm-hmm.
Then it's projected to hit $233.6 million by 2025. But the really interesting figure is, looking out to 2033, we're talking about $342.043 million.
Wow, yeah.
That's a steady global compound annual growth rate, the CAGR, of 4.882%. That's solid, consistent growth. Shows how integral they are.
Definitely. A strong upward trend.
Okay, so that's the big picture. Now let's maybe break this down a bit, see where this growth is really happening region by region. Let's kick things off with North America. So the region generated, what was it, $68.34 million in 2021?
That's right.
And projections show it expanding pretty significantly to $114.584 million by 2033. The CAGR there is 4.403%. What's driving that?
Well, it clearly points to, continued investment in high-power applications. The U.S. Leads the way there. It's projected to reach nearly $90 million itself by 2033.
20 million, just the U.S.
Yeah. And that growth is largely fueled by things like data centers, big ones, also electric vehicle infrastructure, that's huge, and just modernizing industrial automation. All these sectors, they heavily rely on that precise, safe power management these photocouplers provide.
Okay, and while the U.S. is the big player, Canada's growth rate is actually a bit higher, isn't it? Over 5% CAGR.
That's right. Yeah, it's on track to nearly double its market size by 2033, starting from about $8.3 million.
Impressive. What does that suggest? A growing industrial base?
It certainly suggests a burgeoning industrial sector. Yeah, maybe areas like advanced manufacturing or energy management systems. And Mexico's showing healthy expansion, too, around 4.6% CAGR. Industrialization continues there.
Got it. Okay, let's hop across the Atlantic. Europe. Their market was $42.085 million in 2021, forecasted to grow to over $70 million by 2033. CAGR is similar to North America, about 4.445%.
Right. And what's interesting in Europe is how it reflects their, really deep-rooted industrial base, but also that strong push towards green technologies.
Ah, right, like EVs and renewables.
Exactly. Germany, for instance, big growth there. Projected to hit over $15 million by 2033. A lot of that is tied to their huge automotive sector, especially the shift to EVs, and also their leadership in high-end industrial machinery.
Makes sense.
And you see similar trends elsewhere. The UK, France, Italy, all expanding. It points to widespread adoption in manufacturing and energy sectors across the board. Spain actually has a particularly strong CAGR, almost 4.8%. That suggests maybe increasing industrial modernization, maybe investment in renewable energy infrastructure, too. Those inverters need these parts.
Yeah, the focus on green tech and modernizing industry really comes through. Okay, but if we're talking about potential, you flagged Asia Pacific. You said remarkable growth.
Oh, absolutely. Poised for remarkable growth is the phrase. It has the strongest regional CAGR by far, 5.706%.
Wow.
Starting from about $53.7 million in 2021, it's projected to almost double, hitting over $104 million by 2033.
Over 100 million. Okay, so what makes APAC such a powerhouse for these components?
Well, it's the sheer scale of industrialization and just the pace of tech adoption across the region. It's kind of unparalleled. China, obviously, is a dominant force, expected to reach over $29 million by 2033.
29 million.
Yeah. And it's not just existing factories. It's China's massive investments in EVs, 5G infrastructure, smart manufacturing, all huge consumers of these precise gate drivers.
Okay, China's big. But then you mentioned India, highest KGR anywhere.
That's the one that really jumps out, yeah. An astounding 6.446% CAGR.
Wow.
It's projected to more than double its market, from around $8.6 million in 2021 to over $18 million by 2033. It just highlights India's incredibly rapid digital transformation and expanding manufacturing base.
That's really something.
Absolutely. And beyond those two giants, you've got Japan, a leader in robotics and automation, showing strong, steady growth. South Korea, too, with its electronics industry. And even Singapore shows a really robust PAGR, over 6%, reflecting its high-tech hub status. It's just this broad embrace across the whole region, a massive push towards advanced power management.
Okay, APAC is clearly the growth engine. Let's shift focus now to South America. The market there was $12.7 million in 2021, forecasted to reach over $23 million by 2033. Still a strong key AGR, over 5%. What's the story there?
It really speaks to the ongoing industrialization and infrastructure build-out in key South American economies. Brazil, being the largest economy, naturally plays a big role. Its market's growing to over $9 million. That growth is linked to their expanding manufacturing sector, plus just increasing demand for efficient power solutions generally.
Right. And you flag Argentina. It's a steep rise.
Yeah, definitely want to watch. A very strong CAGR, almost 5.7%, projected to nearly double its market share. It points to, targeted investments in industrial modernization, maybe renewable energy projects too. And you see Colombia, Peru, Chile also contributing to that upward trend.
Okay. How about the Middle East? Also growing steadily, right? From about $10 million to over $18.5 million by 2033. Siegel bar around 5%.
And this really highlights the region's broader economic diversification efforts. They're moving beyond traditional industries, investing in tech and modern infrastructure.
Like the UAE, their key GR is quite high too.
Exactly. The UAE shows a particularly strong AGR, nearly 5.8%, growing to over $3 million. This reflects those really ambitious projects in smart cities, renewables, data centers, all needing sophisticated power electronics.
Got it. And it's not just the UAE. Saudi Arabia is set for significant growth as well.
Yeah.
Plus Turkey, Egypt, Qatar. It paints a picture of a region really building out its tech capabilities.
That's the picture, yes.
All right, finally, let's round out the regions with Africa. Starting from a smaller base, just under $6 million in 2021, but expected to nearly double to over $10.8 million by 2033. The CAGR is a bit lower, 4.4%, but still solid growth.
Yes, and these figures, they kind of indicate a foundational build-out, basic industrial and tech infrastructure. Nigeria, as a large, rapidly developing economy, shows consistent growth, and South Africa, too, which has a more established industrial base. The growth isn't as explosive as, say, Asia, but it's a vital indicator. Points to increasing power grid stability, some emerging manufacturing, broader digital adoption across the continent.
Okay, so we've toured the globe.
We have, and bringing it all together, the global optoelectronics IGBT and MOSFET gate driver photocoupler market, it's just set for incredibly steady, consistent growth everywhere. We see standout performance, obviously, from Asia-Pacific, driven by manufacturing and tech, but also significant growth in emerging markets, like in South America and the Middle East, as they modernize.
Exactly. And that global key AGR, nearly 5%, shows this isn't just incidental. This market is proving absolutely essential for, well, power electronics, industrial gear, energy-efficient tech. List goes on. So what does this actually mean for you, our listener?
Well, maybe consider how these seemingly small, very specific components are quietly enabling these massive shifts we see every day towards automation, better energy efficiency, more advanced computing, from, charging your electric car faster and safer to making a factory floor run smoothly. These hidden heroes are doing the work. It really makes you wonder, doesn't it? What other hidden hero technologies, these sort of unsung components, might be out there driving the future that we're only just beginning to understand? Welcome to the deep dive. Today, we're digging into something that might sound, well, pretty specialized.
Yeah.
Gate driver photocouplers.
They do sound a bit technical, yeah.
Right. But here's the really fascinating part. They are kind of silently powering the modern world all around you. Think about the electric vehicle you might drive someday, or maybe already do.
Or even just the smart appliances in your kitchen.
Exactly, making your home more efficient, or even like the compact charger powering your phone right now.
Yeah.
These seemingly tiny parts are sort of the unseen architects, really, making our latest electronics faster, smaller,
And crucially, safer. That's a huge piece of it.
safer. Yeah, definitely safer.
That's exactly right. So our deep dive today is, well, it's all about pulling back the curtain on these optoelectronic devices.
Okay.
We'll get into what they actually are, why they've become so incredibly important for some of the fastest growing industries out there.
Like EVs and renewables, you mean?
Precisely.
Mm.
And also the challenges, the hurdles manufacturers face making them. It's not simple.
Right.
And of course, where this whole technology is headed next, we're drawing on some pretty comprehensive market research for this.
Great. So, okay, let's unpack that first bit then. What exactly are gate driver photocouplers? Why are they so fundamental?
Okay, so at their core, think of them as vital components in modern power electronics.
Yeah, electronics, right.
Their main job is basically to create an invisible wall,
Yeah,
protective barrier.
an invisible wall. Okay.
Yeah, they electrically isolate sensitive, low-power control signals from the really high-voltage power circuits.
Ah, I see. So low power meets high power, but safely.
Exactly. Imagine you're trying to control some massive, powerful piece of machinery, right? But you're using delicate, low-voltage electronics to do it.
Like the brains of the operation.
Precisely. If any of that high voltage somehow leaks back across to the control side,
Mm.
well, it could be catastrophic damage, failure.
Not good.
Not good at all. So these devices prevent that. They ensure both safety and really efficient switching of the power.
Efficient switching?
Mm.
Meaning turning the power on and off quickly?
Super quickly and cleanly, yeah. They're essentially what allow those low-power brains to safely command the high-power muscles in a system.
So that invisible wall you mentioned, it's not just like a technical term, it's a fundamental safety feature.
Absolutely critical.
And that's what enables, as you said, pretty much all modern power electronics to even work reliably.
You got it. Foundational stuff.
Okay, so here's where I think it gets really impactful for everyone listening. Let's talk about the major forces driving the expansion of this market.
Yeah, the why now question.
Exactly, because it connects directly to these huge global shifts we're all seeing.
It really does. And what's genuinely compelling, I think, is how these photocouplers aren't just like part of these trends.
Hmm.
In many cases, they're actually the enablers making them possible.
Okay, give me an example.
Right, take electric vehicles, EVs, and industrial automation. Big areas. In EVs, they are absolutely crucial for isolating those control signals within the high voltage powertrains.
Yeah.
Think batteries,
There's
motors.
serious voltage there.
Oh, yeah. Without really robust, reliable isolation, the sheer power involved would just make these vehicles unsafe or unreliable or both.
Right?
It's kind of this surprising hidden reason why your EV can be both incredibly powerful and safe to operate.
Huh, never thought of it that way. And industrial automation.
Same principle, different application. They ensure safe and efficient switching in things like motor drives.
Which are everywhere in factories.
Everywhere. Powering robots, conveyor belts, automated production lines. The core of smart factories, basically.
So the big takeaway is, as our cars and factories get more advanced.
Smarter, more powerful, more automated.
Yeah.
The demand for these specific components just ramps up intensely.
That makes sense. What else?
Well, then there's the massive global push towards renewable energy. That's another huge driver.
Solar, wind.
Exactly. Think about solar inverters.
Yeah.
The boxes that convert DC from panels to AC for the grid or your home,
Yep.
or wind turbines. Large-scale battery storage systems, too. Photocouplers are essential in all of these.
Why there specifically?
Again, it comes down to isolation, maintaining what's called galvanic isolation. That's a complete electrical separation between circuits.
Total separation.
Total.
Mhm.
And also ensuring signal fidelity, making sure the control signals stay clear and undistorted, even in really noisy, high-power environments.
Which you definitely have in a power plant or a wind farm.
For sure. So as countries invest billions, trillions, really, in clean energy to meet sustainability goals,
Which is happening everywhere.
the underlying need for robust, reliable gate driver solutions like these photocouplers in all that power conversion equipment just surges.
Got it. So EVs, industrial automation, renewables.
Yeah.
What about like everyday stuff?
Good point. Don't underestimate their role in the relentless drive for miniaturization and efficiency in consumer electronics.
Smaller and uses less power.
That's the goal, right?
Yeah.
Every smart appliance, every tiny phone charger, your laptop power adapter.
Yeah, they keep getting smaller.
Exactly. They all need high-speed switching, but packed into ever-shrinking spaces.
Okay.
Photocouplers help meet those really intense performance demands while also ensuring thermal stability, keeping things cool enough, and that critical electrical insulation.
So they're doing multiple jobs in that tiny space.
They really are. They're kind of the unsung heroes, allowing our gadgets to be smaller, safer, and way more power efficient than they used to be.
That really paints a picture. They're central to the energy transition, automation, even our gadgets. But, no market grows this fast without challenges.
Yep.
So what are the biggest headaches, I guess, for the manufacturers actually making these things?
Yeah, that brings up some pretty significant hurdles. One is definitely design, complexity, and integration.
Complexity, how?
Well, developing gate drivers that can precisely handle the huge range of different voltage levels, current demands, and switching speeds needed for both major types of power transistors, IGBTs, that's insulated gate bipolar transistors,
Right.
and MOSFETs, the metal oxide semiconductor field effect transistors. That's just inherently difficult. They have different needs.
So it's not one size fits all.
Not at all. And then trying to integrate these already complex components into the tiny, densely packed multi-chip modules that everyone wants now.
For those smaller devices.
Exactly. That requires really specialized design expertise.
Yeah.
Honestly, this complexity can sometimes slow down adoption for some OEMs, the equipment manufacturers.
I could see that. What else?
Another major concern, especially for these optoelectronic solutions, ones using light, is reliability under extreme conditions.
Because they use light. How does that affect reliability?
Well, unlike purely electronic isolators, these photocouplers rely on a tiny internal LED light source and a photodetector.
Light transmits the signal across the isolation gap.
You got it. But the performance of those optical components can degrade over time when they're exposed to sustained high temperatures.
Which you'd find.
In industrial settings, definitely. Or inside an EV's powertrain system, for example. High humidity can also be an issue sometimes.
Okay.
So ensuring long-term durability and consistent performance in those really demanding environments puts immense pressure on manufacturers. They have to meet incredibly rigorous quality standards.
Makes sense. Safety critical stuff needs to be tough.
Absolutely.
Yeah.
And then we can't ignore the competition.
Alternatives.
Yeah. There are other ways to achieve isolation. Digital isolators, which use different technologies like capacitive or magnetic coupling,
Okay.
and also transformer-based gate drivers. These are becoming strong contenders.
Why? What are their advantages?
Often they can offer, say, better thermal performance, maybe faster switching speeds in some cases, or even smaller physical footprints.
So photocouplers have rivals.
Definitely. It means these optoelectronic solutions aren't just sitting back. They're under constant pressure to innovate, to improve, just to maintain their competitive edge.
That's a really good point about the specific challenges for opto solutions. But despite these hurdles, the market's clearly growing. So what's exciting? What's coming next?
What are the innovations driving things forward?
Yeah.
Okay, yeah, the future here is actually incredibly dynamic. One of the most significant trends, maybe the most significant, is the adoption of wide bandgap semiconductors.
Wide band gap.
Like materials like silicon carbide size and gallium nitride GaN. You hear a lot about these now?
SiC and GaN, right. I've heard those terms.
They are genuinely revolutionizing power electronics.
Yeah.
Why? Because they can switch power much, much faster than traditional silicon.
Okay, faster switching.
And they can handle much higher voltages and temperatures. More efficient, smaller systems become possible.
So how does that connect back to the photocouplers?
Well, these new SiC and GaN devices demand gate drivers that can keep up with their speed and handle the higher isolation voltages needed.
So the driver has to match the transistor?
Precisely. So this is directly pushing the evolution of new high-speed optoelectronic gate drivers, specifically engineered to support and really unlock the full potential of these next-gen semiconductors.
So faster materials need faster gate drivers. Makes sense. What else is new?
Another fascinating area is how these gate driver photocouplers are becoming smarter.
Smarter how? Like AI?
Hey, not quite AI, but definitely more intelligent.
Yeah.
Manufacturers are integrating advanced protection features right into the component itself.
Such as?
Things like fault detection sensing, if something's wrong with the power transistor. Thermal shutdown, so it protects itself if it gets too hot.
Okay, built-in safety nets.
Exactly. And soft start capabilities, which help manage the power smoothly when things turn on. Stuff like that.
And why is that important?
Well, these integrated smarts really simplify the overall system design for engineers. It makes the whole thing safer, boosts reliability.
Less chance of things going wrong.
Right. Especially crucial in those critical automotive and industrial applications where, failure just isn't an option.
Yeah, absolutely. Anything else on the horizon?
One more key trend is the shift towards opto-isolated digital interfaces.
Digital interfaces
Yeah,
instead of
yeah.
analogs.
As the control systems, the brains increasingly use digital communication protocols.
Like in modern cars or factories.
Exactly. Photocouplers that have digital logic built right in alongside the optical isolation are becoming really popular.
And the benefit there is,
It's not just a minor technical detail.
yeah,
It dramatically improves noise immunity.
meaning they handle electrical interference better.
Much better, which is a huge deal in noisy electrical environments.
Yeah.
And it also allows for much more compact, streamlined circuit board designs,
Ah, fitting more into smaller spaces again.
which is always a goal, especially in high-density systems. It helps keep everything neat and tidy on the PCB.
Okay, wow. So if we kind of step back and look at the whole picture,
Yeah,
this market, the optoelectronics IGBT and MOSFET gate driver photocoupler market,
it's a mouthful.
it is. But it really seems to sit at this crucial crossroads, doesn't it? Between high voltage safety, cutting edge digital innovation, and this massive global energy transformation that's underway.
That's a perfect way to put it. Yeah.
It feels like they're less of a niche component and much more like an indispensable building block for our electrified future.
I think it's absolutely right. As industries all over the world continue this profound shift, electrifying transport, digitizing manufacturing, moving to renewables, the importance of these, you know, seemingly small, almost invisible components,
Yeah.
it's just going to keep growing exponentially, really.
Yeah.
And they're being pushed forward by this wave of new materials like SiLi and GaN, smarter integrated features, new digital approaches.
It's a very active
Very active, constant innovation.
So that leaves us and everyone listening with maybe a final thought to chew on. How will this relentless global push for more electrification, more digitization, continue to stretch the boundaries of what these components need to do? How will it make these seemingly small parts even more pivotal in the future that you live in?